All right. So here, oh, let me share. Did I? I didn't share it. All right. Which ones do you want to go over?
All right, I just so I finished the full first page and I looked at a few problems.
Okay.
There's like so many questions that to go over. I feel like we should just do like one on each page maybe
Okay.
or two on each page. Just
All right.
to
This is the whole year, yeah, full year geometry review pack. Okay. And when is your exam?
it's tomorrow, but I've been studying for a while now, so
Okay. All right. All right. Tell me which ones you wanted me to go. Let's go over.
slope, I'm good with slope. Slope
All right.
is simple.
All right. Slope. Identify each pair as a parallel. Okay, that one's slope. Find the length of the line segment connecting. Okay. Some word problems. More word problems. Use the same can of tennis balls in the previous question. Find, keep exact. Total volume of the can. Okay, volume question. Radius, find the radius and center of the circle with the equation that. Okay, just complete the square on that. Describe the graph of the equation. This radius. Oh yeah, this one just complete the square. Put it in the right form.
Yeah.
What is the diameter of the circle? Yeah, same thing with this one. Diagram below is a square pyramid. If the volume of the pyramid is that and the length of one side of the base is that, what is the height? Just use the formula for that one. 18, density of a gold necklace is that and mass that. What is the volume to the nearest hundredth? Just use a formula for that. Okay, what is this one? Similar, pyramids are similar. Find the volume of pyramid X. Oh no, the volume of pyramid X is 216. Find the volume of the other one. Okay, solve for the variable in each diagram. Round to the nearest hundredth is necessary. Just set up your ratios for that one.
Yeah.
22 area of the circular base. Round, okay, just use your formula for 22. 23, how much more air to the nearest tenth can Tom Brady pump into the basketball before it's fully inflated? That one, just use your volume formula of a sphere. AB, line segment AB is partitioned by the point in a ratio of 1 to 3. What is the y coordinate? What is the y coordinate of J? For 24, first use your line segment formula to find the distance of AB.
Yeah.
And then just say it was like 21, for example. You know that it'll be, it says 1 to 3, right? In the ratio of 1 to 3. What is, okay, so for this one, just say the line segment was 21, for example. Then you would go in the X direction, like a certain amount, and then the Y direction, a certain amount.
Right.
Then you would find the Y value of the coordinate. 25, ABC, triangle ABC is transformed. Which transformation below will not always allow the statement that to be congruent to that to be true? Okay, it'll be this first one. Which transformation below will not always allow the statement that to be true? Yeah. Well, let me think about this. This one, yeah. This one, yeah. Yeah, yeah. It would be this first one. Mr. and Mrs. Smith share a love of coffee. In the morning, Mr. Smith makes a large pot of coffee and splits it evenly between their two uniquely sized mugs. The mugs are cylinders that hold the same volume of coffee. Mr. Smith drinks from a mug with a circumference of that and a height of that. Miss Smith's drinks is much wider, circumference that, but is shorter. What's the height of the lady's mug to the nearest hundredth? For that one, just use your formula for volume of a cylinder.
Let me find my. I have a. They're gonna give us a reference sheet of all
The formulas?
Yeah.
Okay, yeah. That's good. So you good on 26?
Huh?
You good with 26?
Yeah, you just have to plug in the the cylinder volume formula, right?
Yeah, exactly. Cylinder volume, the volume for a cylinder formula is, what do you remember off the top of your head?
No, I'm looking for the reference sheet real quick.
All right. I think you had one at the end here. No, let me see. You know, just Google formula for cylinder. And yeah, you just plug it in the formula and use the given information.
Yeah.
What was that? 20? Oh, there's a lot of questions, man. A lot of questions here. The whole year. Okay, 20. Yeah, that was 26, 27. Rectangular polygon is picture. What is the sum of x and y? Okay, x and y right there. What is the okay? So these are both radiuses, right? These are both radiuses.
Yeah.
So x should equal y. So it really should be let me see here. If I go to black, so this and this are the same length, which means that this angle is this angle. So what is the sum of x and y? It should be 120. Do you have the answers for this?
No, I have no answers.
Didn't give it. I'm thinking for that one 120 because that's a radius and that's a radius. So if you add them together, it's I'm thinking it's a
16.
I'm thinking that's 60. So this is 60 and this is 60. Isosceles triangle. Or sorry, equilateral triangle, equilateral triangle.
Yeah.
So it's asking for the sum of the two bottom angles. That's 27, 28. Find the midpoint of AB with coordinates that and that. There's a formula. Just use the formula for that one. 28. 29. In the following diagram, that is congruent to that. Angles that. Show that triangle ABC is congruent to GFE by applying the following algebraic descriptions that would map triangle GFE onto a triangle ABC. Okay, so what they're saying is XY to something, something followed by XY to something. Okay, so that all that means is, let me get the pen up. All that means is, which one's the first one? The first one is GFE. So GFE is this one right here on the right. So basically, how are we taking this one on the right? And how's it becoming this one on the left? What are we doing to the X and Y coordinates?
You're flipping it, kind of like transforming it.
We're doing a couple things, right? So let me see here. So let's write it in order. Triangle GFE, and they want in the following AB is congruent to that. Angle A is G, AC is G. Show that ABC is okay. So here, so they're saying that ABC. So okay, so they're saying that A is the same thing as which one? As G.
Right.
So how does A become G? What do we do to the X value?
You flip it.
In terms of like, yeah, you kind of flip it, but in terms of like, what should we put here though?
You would put the original X and Y value, maybe.
Okay, well let's do that first then. Which one are we working for? Okay, what's the coordinate of A? It is
-6.
it is negative
7.
6, comma 7. Okay.
Yeah.
And then A becomes later on, it becomes what? It becomes G, right?
Yes. And
So
G,
what's the coordinates of G? G is 6, 4, right?
4.
6, 4. Okay, so how do we go from -6 to 4?
Well, do you want the difference of would be like 12, correct?
The difference is 12, but we're kind of doing this, right? We're taking our A and we're kind of like rotating it. Or what do you guys call it? No, you guys call it rotate, or you guys call it no. Yeah, you rotate.
Yeah, rotate.
Okay, so the difference is 12 between those two letters. But like, what are we gonna write here? Followed by, okay, so we're gonna rotate it and then we gotta add something here and add something here to the X and Y. So what should we write there?
Would you just write -6, 7 followed by x plus 6 and then y plus 4 maybe?
-6, 7 here,
Yeah,
followed by what? 6,
maybe,
4 here.
yeah, I think or 12 and negative something. I'm not sure.
All right, let's see here. Okay, we're starting at -6, 7, which is this one right here.
Yeah.
And then we're ending up at this one right here. Okay, so how can we get it looking like this first? How can we get it looking like that first? I didn't draw too good, but like, how can we rotate it so it looks like this one? It's in the same orientation as that one.
Would you make it perpendicular to it or
Not perpendicular, but we want to rotate it how many degrees this way?
90
90. So what would this one be then?
90 degrees maybe?
There's, if we rotate it 90 degrees, that's a reflection about the y-axis, right?
Yeah.
So the x would be, if we wanted to rotate it, so first step is what we want to rotate about the y-axis, rotate about y-axis 90 degrees, about y-axis 90 degrees. In terms of this though, it's basically the x becomes, does the x become negative x, or does the -6 become, when we rotate it about the y-axis 90 degrees, that means let's think about that. The -6 would become what?
Positive?
That would be, that's the second step. That would be number 2. See how it says x plus something? That's what would go in here.
Mm.
Let me just Google what that transformation is right quick. Because I forgot off my head. Rotating about 90 degrees, rotating about y axis 90 degrees. Which way is that? That's clockwise. Yeah, that's clockwise. All right, let's see what the x becomes. Yeah, here, you see right here. Let's how to rotate a point by 90 degrees in clockwise direction. The xy becomes y negative x. See right there? Look, I can't highlight this. Do you see what the I can't, let me write it on. This is what I was trying to see. See, this is your original, right? XY. So now it becomes y negative x.
Oh,
Okay, so that's your 90-degree rotations. That's the first one. So let's go back. Let me erase this. Where is it? So this one becomes what was it? Y negative x. Okay, so now you're -6, 7. If we flip that to y negative x, what's the new thing? What's the new coordinate? Y is 7 and -x is 6. Get it?
yeah. So it'd
Okay,
be
so we're 7, 6. 7, 6 is 7. 6 is right here. 7, 6 is right here, right? 7, 6. Okay, let me go back and make sure I read that properly. Okay, how to rotate a point 90 degrees in clockwise direction. Let's rotate point A, xy degrees in a clockwise direction about the origin. The new coordinates of point A are y negative x. Y and negative. Okay, yep. So that's the first thing. Okay, so now we're there. Okay, so do that for all 3 points now, right? Okay, so what were the, oh, sorry, I should have wrote it down here.
Oh, by the way, for the I think there's a YouTube video for the packet that goes over it, I'm pretty sure.
Oh, the answers?
Yeah.
Okay. All right. All right, just keep that link. We'll use it if we get stuck.
All right.
All right, B is -4, 5. And that goes to what? B goes to F, right? What's the coordinates of F? F is 4, 2. And C is what? C is -9. C is -9, 3, right?
Right.
And then C becomes what? E. E, right? And what's the coordinates of E? E is 2, 7. 2, 7. Okay. So step one. This. Okay. So what does 4, 5 become after step one? Remember, it's switch to y first, and then -x. So y first, 5, and then -x, 4. Okay, so that's step one. And then about the C is -9, 3. What does that become?
But I'm not sure. Can you explain it?
Okay, you understand these coordinates right here?
Like those are the ones on the
The left.
graph. Okay.
Okay, so now these ones are on the ones is the triangle on the right. This one.
Okay.
Okay, so I'm just writing them in order, right? A becomes G, B becomes F, and C becomes E, right?
Yeah. So C would be 2, 7,
That's E.
E.
See this right here?
Oh.
A becomes G, B, F, and C, E. A, G, B, F, C, E. Right?
Oh. Okay.
All right, so it's like the before and after.
Right.
Okay, so now first step was switch the X and the Y. Or sorry, the X becomes the Y, right? The X becomes the Y, and the Y becomes the X, -X.
Yeah.
So in this column, here's your original. Now I'm switching the Y. I'm writing the Y first, and I'm writing -X second. So on this one, I'm going to write the Y first, and then the -X second. Okay. All right, that's the first step. Now, what do we do with those steps to become the triangle on the, so this is step one right here.
Right.
Now, step two. Okay, let's draw these coordinates on the graph. So where are we? 7, 6. 7, 6 is 7. 6 is right here. 5, 4 is 5. 4 is right here. And 3, 9. 3, 9 is right here. Okay, so how does this triangle in red become the black triangle that's just beneath it?
It's brought down a little.
It's brought down how much? How much is it brought down in the, how much is, okay, we're going to talk about the X direction first. How much is this point moved left or right to become the new point?
It moved left 1.
Okay, so X -1 there, right?
And then 2 units down.
There you go.
Mm.
There you go. Now,
Okay.
then you'll have this point, and this point. Get it?
Okay.
So the answers are put the Y there, put the -X there, -1 there, -2 there. It's just kind of like draw the triangle step by step.
Okay.
Draw the triangle step by step. All right, that's 29. Let's see what else we got. Or so take a picture or write that down.
Okay.
You got it. All right, clear that. All right, that was 29. What else we got? 30. Mass of a steel bar is that for 7.9 meters cubed. What is the density of the steel bar to the nearest tenth in so You just divide it. Just it wants kilograms per meter squared. Just take your kilograms and divide by and just divide by the 7.9. And it says nearest tenths. Tenth is well, how many decimal places? That's
So you would get 63,000
yeah. Let's see what it is.
divided by 7.9.
Yeah, 63,890 divided by 7.9. This answer will be in whatever you get here will be in this right here, kilometers per meters cubed. Kilometers per meters cubed. Whatever that works out to be, about like 8 something, 8 point something, or 8,000 something.
Yeah, 8,087 point.
8,087. Now just give me 2 decimals. It says no, 1 decimal. It says tenth. 1 decimal. What is it to 1 decimal?
Oh, 8,087 dot 3.
8087.3
Yeah.
kilograms per meters cubed. Here's your answer right here.
Oh, so it's just division then.
Yeah. See, look at the units they want you. Just kilograms per meters cubed. They give you the kilograms. They give the meters cubed. Just divide it.
Okay.
That one's pretty straightforward. The only thing would be different if they asked you for some kind of other unit, then you would have to do the conversion. Okay, so that's 30. Fill in the blanks below. Are you good with 31?
Is it can you go over that one real quick?
31. Okay, so it's kind of like opposite. All right, so sine 25 is going to be the same thing as cos what's 90 minus 25? 90 minus 25 is what, 65?
Yeah.
So just double check that for me.
Yeah, 65.
Okay. Oh, you're looking at the answer?
No, I have my calculator.
Okay. Yeah, just make sure those two are the same thing.
So how do you get 90? Where did you get 90? Cosine?
It's just kind of like something you should know. Like 90 is like from here to here, and then here to here, here to here, here to here is all 90, right?
Yeah.
So if you just look at one quadrant, sine 25, or actually not at one quadrant. Let's do it like this. Let's draw a little triangle. We know that sine is opposite over hypotenuse, right? This is sine, right?
Yeah.
So let's draw a little triangle. So here's our triangle. Here's our right angle. Okay, so this is our hypotenuse. And here's our, or you guys call it theta. Here's your theta. Let me undo that.
I'm pretty sure it's like SOHCAHTOA.
Yeah, exactly. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right. So for this one, they're saying that.
And then what does the ka and the toa, like, what do they look like as well?
They're similar. They're similar. It's just I'll show you. All right. So let's do this one right quick. Okay, so sine theta would be opposite. This one would be your opposite, and this one would be oh no, sorry, my bad. It's 25. This is your 25 here, 25 degrees. This would be your 65 degrees, right?
Yeah.
Because the 3 of them together have to give you 180, right?
Correct.
So if they give you the 25, you know this is 90, so automatically you know this one is 65.
Okay.
All right, so for B, same idea for B. Same idea for B and C, actually. All 3 of them. Okay, so this one would be sine. What would this part be?
Sine.
Think about what we did here. How do we get to 65? 90 minus this one.
So 90 minus 65?
90 no 90 minus this one right here.
Yeah.
Would be this one right here.
Right.
So same idea on B.
So 90 minus sine, like
90 minus x. 90 minus x.
What would that be?
This one would be just 90 minus x.
Oh,
If this is x right here,
yeah.
if this is x right here, then just take this one would just be the difference, 90 minus x. Just like this one, right? This is the same thing as cos 90 minus this one, 90 minus 25, which is 65, equals cos 65.
Okay.
So same thing with this one. It's just the difference of this one right here. 90 minus that difference right there. Sorry, not 90 minus the difference. 90 minus whatever the cos is there. So 90 minus x for that one. What about this one? This one is sine 80, right? Switch the trig ratio. Cos becomes sine, and then this one is 80 there, which is your 90 minus 10. Right? This is your 10 right here. 90 minus 10 is 80.
Okay.
Get it? You just got to kind of know the relationship between the two of them, cos and sine, or sine and cos.
Okay.
Good on those three?
Yeah.
Here.
Let me take a photo. Let me take a
Oh, let me undo that. There. Yeah, take a photo of that one.
Okay. All right.
All right, let me clear that one. All right, that was 31, 32. 32 is a word problem. How many miles is the race? Round your final answer to the nearest tenth of a mile. A marathon race in Utica, New York requires competitors to run around 3 city landmarks: the teacher, bank, and hibachi restaurant, a total of 3 times. The theater is located at 6-7. That's the one in the upper left. Bank is at 8-2, the piggy bank, and the restaurant is the fork and the knife. Each unit on the map represents a mile. How many miles is the race? So basically just take your connect these 3 points, right? Connect those 3 points, and then what are you going to do after that?
So
You know this coordinate.
you have to find the area, maybe?
Not the area, but the
perimeter.
Yeah, exactly. How many miles is the race?
The mile. All right. Yeah. Okay.
A marathon race in New York requires competitors to run around 3 city landmarks, a total of 3 times. So basically get this distance, this distance, this distance, add them up, and then multiply by 3.
Okay. So how would you go about adding them up?
You could use your just say this is A, this is B, this is C. Just use your distance of a line formula. So you'd say AB equals, you'd get that distance. You'd say BC equals, get that distance, and then CA. So same idea. You're going to do, what is it? X2 minus X1, square that. I think it's subtraction. Is it? I think it's add, and then Y2 minus Y1.
Oh,
squared.
okay. I see. Because it says on the reference sheet right here the distance formula.
Is it this? If I'm remembering off the top of my head correctly, is it?
Yeah. It's like that.
So same thing for this one, and then same thing for that one, right? And then you add them up. Just say this was 10, this was 7, and this was 11, right?
You add them up and then multiply by 3.
Exactly. Yeah, there you go.
Okay.
Now the only thing is you got to do the math on each of these, right?
Right.
Yeah, but that's the idea.
Okay, that makes more sense.
Yep. All right, let me actually redo that if you want. Can I redo it? Undo? Yeah, that's the general idea. Now you just have to plug in the right coordinates and take the square root of those.
Right.
All right. Okay, so that was 32. 33, a circle has center of that and diameter has coordinates of that and that. What is the value of y? Center has a circle of that and a diameter has coordinates that and that. Okay, what is the value of y? Okay, for that one, I need to draw a little picture. If I draw a picture. Okay, so okay, we'll draw it on the same coordinate here. -3, 2, -3, 2 is right here, right? There's your center. Okay, so the circle has a general formula of this, right? X minus h squared plus y minus k squared equals radius squared. That's the general formula of a circle. Now they give us the center already. This is center HK. HK is the center.
Right.
Equals center. So they give us the center already. The center is -3, 2, -3, 2. So we're going to plug that in right here automatically. It's going to be the opposite sign. So x plus 3 squared plus y minus 2 squared. And what we do have to do is find the radius here. Okay, so there's our center right there. The diameter has coordinates of 5, 6. So where's 5, 6? 5, 6 is right here. 5, 6 is right there. So that's the diameter has coordinates of 5, 6, and x, y. What is the value? Okay, so what is this distance called right here? What's that distance right there? This is the center, and this is
That would be the diameter.
the edge. It's the edge. I
Uh,
didn't draw it too good, but it's the edge. So basically, you could calculate this point right here. This is 5, 6. You can calculate this distance using the distance formula, and then you would plug it in here. This is a radius. This is your radius right here. So you'd use the distance formula,
yeah.
find out what r is, square that, and put it right here. And what do they want? They want the value. What is the value of y? Okay, so they want to know what the value of. So if you know the radius, then just say the radius was 5, for example, right?
Hmm.
Then 5 in every direction. 5 up here, 5 down here, or to the left, I meant 5 down here. And that would be your circle.
Right.
So then the question to this is, what is the value of y? Circle has a center that the diameter has coordinates 5, 6, and x, y. Once we know the radius, we could it's either going to be directly above, directly to the left, or directly below the center. What is the value of y? I'm thinking they should have gave you this here, because then it could be this one, it could be this one, or it could be this one.
Hmm.
What does it say on your answer sheet for 33?
It says the answer is -2.
-2. So they're saying the y value is -2. Yeah, that means it means it's this one on the to the on the directly below the center. 3, -3, 2. Yeah, that's right. So they're saying that radius is 1, 2, 3, 4. Is this a 4 right here? 4 squared? Did they give you the circle formula or no?
For the circle formula, it's like 2 pi radius circumference, or like area pi radius.
You have the electronic version. Share your screen. Let me see. Let me see that one. Let me see that one.
I don't have the reference sheet.
Oh, you don't. Oh, okay. Oh, you have a hard copy of it, right?
Yeah, I'll tell you. It's for the circle. It's a equals pi r.
Hold on a sec. I didn't mean to do that. I meant to first share my screen. I didn't mean to erase what I wrote. How do I get it back? Can I get it back? Undo. Damn it. All right, just tell me.
For circle, it's a equals pi r to the power of 2.
Okay, so they're finding the volume, the area. Why would they want to find the area? And they're saying the answer was -2.
Yeah, there's also another formula for the circle.
33. Would you take a picture? Okay, that doesn't make sense though. That doesn't make sense. I don't know
Well,
why you want to
I can
find.
share my screen for the explanation.
Yeah, share your screen for that one. Because that's two-dimensional.
5, 6, and x, comma, y. What is the value of y? Okay, I'm going to try and draw a fancy circle, so bear with me. Okay, it works. All right, now, this circle has a center at -3, 2. So I'm going to put a point, and we're at -3, comma, 2.
Yeah, okay.
The diameter, which goes through the center, okay, so your diameter always passes through the center. It's a quick sketch.
That one on the right is 5, 6.
6, and
Yeah.
the other one is missing. So we have one endpoint that they gave us. It's
Okay,
5,
yeah. It's
six.
sorry, the one on the left, not the one on the.
Huh?
It was the one on the. Okay, so she's writing 5, 6 on the left. That can't be possible. Through -3, 2 has to be. -3, 2. Okay, hold on. Let me share my. Okay, pause it right there. Let me share my screen.
All right.
Let me go back to the graph. Okay, what was the center? The center was -3. You can see my screen, right?
Yeah.
-3, 2 is right here, right?
Oh no, I can't see your screen. No.
Oh no. Share screen. This one. Can you see it now?
No. Wait, let me.
Is it because you were sharing? Can you see? Okay, can you see now?
Yeah.
All right, so all right, let's go back. Okay, so the center 3, -2 is right here. -3, 2 is right there, right?
Right.
Now they're saying 5. Okay, so that's that's that one right there. Now they're saying the diameter of the coordinates is 5, 6. 5, 6 is up here. Now the way she drew it like this. There's your center, -3, 2. But now she's saying 5, 6 is over here. But look at the graph. 5, 6 is right there. -3, 2 is right there. So that doesn't make sense. That doesn't make sense. But anyways, play the video. Let's see what she said. Yeah, she has 5, 6 on the left.
From y. The question is, what is the value of y? Well, this is a question where we're given the midpoint, we're given one
Oh, okay,
endpoint,
midpoint formula. I got you.
solve for the
Yeah.
other endpoint. I like to go about it visually.
As soon as she said midpoint, yeah, I got it.
And this is how I do it. I stack the 2 coordinates that I have with the
You
midpoint.
should really reverse it and then use the midpoint formula. But yeah, that's how you do it. Midpoint formula. You remember the midpoint formula?
Yeah, I have it right here.
Add the 2 x's, divide by 2. Add the 2 y's, divide by 2.
Yeah.
Okay, yeah. That just refreshed my memory. Yeah. As soon as she said the word midpoint, yeah, my brain clicked.
Yeah.
Right.
5, 6. My endpoint. My midpoint goes in the middle. -3, 2. And then my other endpoint, that's what I need to solve for. Now, since it's the midpoint, what happens above the midpoint and below the midpoint should be the same. So what I'm going to do is I'm going to figure out how do I get from 5 to -3 on the number line. To get from 5 to -3, I have to subtract 8. So I'm going to repeat that on the other side. -3 minus 8 gives me -11.
And then same thing on the y's.
Let's do it again for the y's.
Yeah.
To get from 6 to 2, I'm subtracting. I'm subtracting
And
4.
2 minus 4. Yeah, that's your -2. Yeah, okay.
2
All right, cool. All right, let's go to the next question. All right, let's see. Okay, so that was 33. 34, the endpoints of two segments are given. State whether the segments are congruent. Okay, K is that, L is that. L is that. Oh no, I think I got to share. I didn't share. Okay, 34. State, no, what's it say? The endpoints of two segments are given. State whether the segments are congruent. Okay, so you just graph those two, and basically, they would be congruent if they're the same length. So you just check your lengths on both of them. Actually, okay, you could just do it roughly. Let's see what we got. How do you go from -5 to -12? You what? Subtract 7, right? -5 minus 7 is -12. And then how do you go from 12 to 8? You subtract 4, right?
Yeah.
Is that the same thing? No, that doesn't make sense. On this one, you would just use your line segment formula, check the line segment length of KL, and check the line segment of MN and see if they're the same. If they're the same, then they're congruent. If they're not the same length, then they're not congruent.
So what's the line segment formula? I don't have it here.
Line segment formula is like this. KL line segment would be -5. All right, let me just write it in terms of x and y. x2 minus x1 squared plus y2 minus y1. y2 minus y1 squared. Take the root of that. Make sense? And then you do the same thing for mn. Just say this was 5. Just say this worked out to be 5. If this worked out to be 5 also, then they would be congruent.
All right, let me take a photo of that. All right.
But if they did not, if this one was 5 and this one was 7, then this is not congruent.
Okay.
Basically, if they're the same length, they're congruent. If they're not the same length, not congruent.
Right.
All right, that's 34. Two triangles similar with a scale factor 5 to 6. What is the value of x? For 35, just set up your ratios. 36, find the value of x and identify the scale factor that maps CBD onto SRT. Same thing, set up your ratios. 35, 36, set up ratios. Point P partitions directed line segment AB in the ratio of that. A is that, B is that, find the coordinates of P. Okay, so you would draw A, you would draw B. Point P partitions directed line segment AB in the ratio of 2 to 3. Okay, so graph A, graph B, find that distance, and then break that into 5 parts. That length would be 5 equal parts, and then just section off 2 of those parts, and then the remaining would be the other 3 parts. And then you would know what this coordinate is. You want us to do this, or
Yeah, can we
want us to do this? Okay, all right, let's do it. All right, let's do it in red. All right, so -8, -8, right? -8 is right here.
Right.
2, 7 is right here. All right, so this one is A, and this one is B.
Right.
Okay, so now let's draw a line, A to B. So what we're gonna do is find this length right here, using our length formula. So
Okay.
AB line segment is square root of x2 minus x1 squared plus y2 minus y1 squared. Now just plug everything in. A, what's the two x values subtracted from each other? -8 minus 2 squared plus The difference of the y's. -8 minus 7 squared. All right, what is that?
So you just find the difference between the x's, and then after that, the difference between the y's.
Yeah, and then square. Yep, exactly. Take and then take the root. Yep. So this is -10 squared plus -15 squared. So what is that? That's 100 plus what? 225. 100 plus 225, 325.
You're right.
What's the root of 325?
Okay. Root of 18. Just 18.
Exactly 18 exactly.
It's 18.0 like 27 blah blah blah.
18 point okay 18.02 something.
27, yeah.
Okay, so approximately 18, right?
Yeah.
Okay, so now that's the distance of AB. It's approximately 18, right?
Right.
Okay, so now we're going to take the 18 and we're going to divide it in this ratio right here, 2 to 3. Okay, so we're going to take our 18. Okay, so how can we do this? What's 18 divided by 5? What is that number? About 3 something? 3.6? The 3.6?
3.6, yeah.
Okay. So what's 3.6 times 2? That's 7.2. And then 3.6 times 3. Do 3.6 times 3 for me.
3.6 times
3. Yeah, and 10.8 is it?
wait, 3.6 times 3. Yeah, 10.8.
Okay, so that's the ratio right here. Okay, so we're going to start off on A, right?
Yeah.
Now we're going to go, let me think about this. We are going to go, so the hypotenuse would be 7.2, but the question is, how much do we go in this direction? How much do we go in this direction? All right, so let's see here. Actually, there's a different way. Can we do this a different way? Okay, the line segment is about 18. Point P position partitions directed line segment AB in the ratio of 2 to 3. 2 to 3. Okay. All right, so let's go. Okay, if the whole line segment is 8, just say it was 18 exactly.
So the answer would be 18.
No. Hold on a second. Let me erase this. Okay, so let's draw a smaller triangle right here.
Okay.
The hypotenuse is 18, right?
All right.
Okay, so this is A right here, and this is B right here. This is B, this is A. And the question is, P is somewhere along AB, but it's closer to A. Here's P somewhere. This is your 2 and this is your 3.
Right.
Okay, so how can we find the coordinates of P? So if P's right here, this part right here is 2 units, and this part right here is 3 units. But we know the whole thing is 18. So how can we find the coordinates of okay, so what's this distance right here? Or not let's draw it vertically, perfectly vertical. So we would, if we know that's 2 right there, if we know that's 2, this would be 1, and then this would be 1. Is that right? 1 squared. No, that would be root 2. Okay, let's see here. If we break the 18 into 5 parts,
Mhm.
this would be 10.8, I think it was, from P to B, 10.8, and then this one was 7.2. So 7.2 plus 10.8 is the 18.
Right.
Okay, so now how do we find the coordinate of this point right here, the P?
Is there a formula for that, or?
It's there's no formula. We would use Pythagorean theorem. The question is, what's this distance right here? And this distance right here.
How would you
If
find
we know that, because if we know coordinate A is this, right? So if we were to start at -8, which is this point right here, if we knew the X value, we would go that to the right. And then if we knew the Y value, we would go that much up. And that's where P would be.
right?
Let's see here. Is any of the? It's probably this point, right? No, it can't be that point. It's probably this point right here.
Okay.
Let's see. Let me just take a guesstimate. It's got to be. It's on this red line somewhere, right? So I'm just looking for a perfect, like this one here. It could be this one right here. What's this point? What is this point? -4, -2. Let's see if this is your 2 units and this is your 3 units. What's the distance between -8, -8, which is this point right here, -8, -8, and 4, -2? You plug it into this formula right here.
It might be also a midpoint formula.
It wouldn't be midpoint because remember the ratio is 2 to 3.
Hmm.
If it was like 3 to 3, that would be the exact midpoint. You know what I mean? So it's slightly closer to point A than it is point B.
Correct.
So let's see here. Yeah, I'm thinking it's that point right there, -4, -2. Can you check your answer on that one? Is it -4, -2?
All right, let me see.
You can also just tell by just looking at the picture.
Is yeah, -4, -2.
-4, -2. Yeah, you can just look on the graph and just say, look, it's not in the midpoint would be somewhere here, right?
Right.
It's closer to A. So I just kind of looked at like which point on AB that's closer to A that looks like 2 units here and 3 units here. So yeah, that's just one way of doing it. Or actually take a picture of that right there.
Okay. All right.
There's a way of finding, if we know A, there's a way of finding this distance. There's basically a way of finding this distance right here and this distance right here. But if you don't know it's -4, -2, I need to see an example just to refresh my memory on that type of question. But if they give you the graph, then just use the graph and you can kind of like estimate where it is.
Okay.
All right, that was what, 37?
All right. Yeah.
All right. Let's see here. You want to skip down? What you want us to skip down, or do you want us just to keep going in order?
Let's do this one real quick. The
38?
volume. Yeah.
Or 39?
39. Yeah.
39. How high is the very top of Fido's doghouse? Find the volume of Fido's doghouse. Round to the nearest 100th for both answers. Okay, so his doghouse is what shape is that? That's his doghouse is 2 shapes put together, right? It's a it's two shapes, right? This is one shape and this is the second shape, right?
Right.
Okay, so the shape of the first one is how high is the very top of Fido's doghouse? Find the volume of his doghouse. Round to the nearest hundredth for both. Okay, that's two decimal places. All right, so first things first. What's the area of the first shape? And then second thing, area of the second shape.
So what about, okay. All right.
So the area of the first shape is what
3 times 4.
3 times 4 times 3.5. Right? 3 times 3.5 times 4. How much is that? What's 12 times 3.5? 42? Is that 42? Is that 42 feet? Feet. Sorry, I said, or what area? I meant volume. Sorry, volume. So what's the volume of shape 1? What's the volume of shape 2? Volume of shape 1 is 42, if I did that right. Is that right? And what's the volume of a triangular prism?
It's like V equals, wait. Yeah, V equals BH. That's the formula.
BH, base times height.
Yeah.
It has to be one more dimension.
It's somewhere here.
We know, okay, so we know this distance is 3.5. We know this distance is 4. And we know this is 2. All right, let me Google volume of a triangular prism. Let me Google volume of a triangular prism. Volume of triangular prism formula. Okay, so it's all this stuff right here. Oh, am I not sharing? Okay, so volume of triangular prism. Let's see an example here. So give us the formula. I should have put in formula. Volume of triangle prism formula. Oh, it's the same thing. Okay, so A is where A is 2 there. What was the other one? The length. Okay, so they're saying base side. That's what, 2? Okay, the only one that it isn't is, so 2, 4, and 3.5. 2, 4, 3.5. Okay, so the question was what the height was. What was the height? Okay, so how high is the very top of Fido's doghouse? Okay, so basically they want this part, this distance right here. If we know this distance right here, we can just add it to 3.
Mm-hmm.
How high is the very top of Fido's doghouse? Okay, so what we have is, let's just look at this triangle right here, right? If we draw that triangle, we know that this is 2. We know that this is 2. Can we find this distance? All right, let me draw that again. If we just look at the triangle prism, the face of it. That's 2, that's 2. But we want this distance right here. We know that this angle is the same as this angle. Isosceles triangle. What else do we know? This is 90, this is 90. What else do we know? Can we find the height there?
Well, so the whole bottom is 3.5. So half of that would just be like 0.75. 0.75 maybe?
This distance is 3.5, right?
Yeah.
Yep, that's true. Oh yeah, so you're saying, okay, yeah, right. 3.5 divided by 2 is 1.75. 1.75 there, 1.75 there, right?
Yeah.
Okay, yep, that's 3.5 when you add them together. Okay, so how can we find h right here?
I'm not sure.
Let's see here. Can we find h there? Can we use you said that volume is base times height, right?
Yes.
We know the base, which is 3.5. Do we know the volume? Yes, we do know the volume. Okay, so this is shape 1. This is shape 2, right?
Mm-hmm.
Volume of shape 1 was was it 42? 3 times 4 times 3.5. That's 42, right?
Yes.
That's the volume of the this rectangular prism, right?
Right.
So volume of shape 2 is what? Base times height. We know the base. We're trying to find the height. Do we know the volume though? Or can we find h? Can we find h in that triangle? If this is an isosceles triangle,
Right.
it has to be that angle and that angle have to equal each other. Okay, if that's 60 and that's 60, this whole thing has to be what?
On it. Still on it. All right. Shuffling music from your library.
What the?
If we just look at one of the triangles, we know this is 2. We know this is 1.75. This is h. Do we know this angle right here?
How would you find that angle?
If we do know that angle, we could use a trig ratio.
Right.
But do we know that angle? No. Is it 60? 60 and 60 is 120. And then 60, oh, that'll be an equilateral triangle. But all 3 sides are not the same. If this is 2, if the hypotenuse is 2, oh yeah, of course. Okay, yeah, my bad. Sorry, late in the day, my brain don't work too good. Yeah, we could just you work backwards. 2 squared would equal, or sorry, 2 squared minus 1.75 squared. That's what h would be. What do you call it? Pythagorean theorem.
Right.
H squared would equal 2 squared minus 1.75 squared. The root of that. That's 4. minus, what's 1.75 squared? 1.75 times 1.75 is 3.0625. The root of that.
Just the
4 minus 3.0625 is how much? 0.9375. Take the root of that number. This is 0.9375. Find out what the root of that is. So h is what?
So 0.9.
9375.
It would just be 0.96.
Okay, so if your height is 0, so this right here, from here to here is h equals 0.9, what was it? 96, what was it?
97.
97. Okay, it says how many? It says 2 decimals, right? Nearest hundredth, yeah, 97. So now your height would be the 3 plus the 0.97, 3.97.
so 6.7 number
Feet. Is check 39 on that one? Check the answer on that one.
Yeah, all right.
Let me check that, double check that on the calculator.
this was knowing how to get the height of just that little triangle, which we did right here.
Yeah, that's what we just did. Yep.
Yeah.
Okay, we have one more question on this page. Let's get
What was it?
to it.
Look, they got 3.97 for the height, and then
Okay, yeah, that's what we got. Oh yeah, we didn't do the volume yet. Okay, so the first one's right. The height is right. For the volume, what they want the volume? How high is the very top? Okay, we did that one. Find the volume of Fido's doghouse. Okay, so now we got the height of, or sorry, we got the volume of the first shape, which is 42. Now we're gonna calculate the volume of number 2. So volume of the second one is base times height. Base we know is this distance, 3.5 times the height, which we just calculated, 0.9 whatever. What is that? 3.5 times 0.97, and then you add that to 42. 42 plus whatever this works out to be.
all right.
Add that right here.
Okay.
Is it 1/3? Shouldn't it be 1/3? Base times height, is it 1/3? Volume of a triangular prism. It's about what, 45 approximately? What's the answer? Is it about 45?
Yes, 48.78.
Okay, all right, yeah, it's an estimate. Yep, okay, that's how you do it. All right, just take a picture of that, or just fill in the detail there, right? I skipped one step there, so just add it to the 42.
Okay.
All right, that's what, 39?
Could we do 40 as well?
All right, 40. Sunkiss is making a new orange juice concoction. The dimensions of the juice carton are provided. 30 height, length 10.5, width 20. Okay. The juice carton is first filled with orange juice up to 23.7 height. Okay, so they're filling the juice up to like this much height first. Next, grape juice is poured in to fill up the rest of the carton. How many cubic centimeters of grape juice is added to the carton? Round to the nearest whole number. Okay. All right, so there's our shape, right? There's the whole box, right? That's the entire box, but they're filling up the box with orange juice, right? First. Next, they're putting in orange juice, then they're putting in grape juice, right?
Grape juice. Yeah.
Okay, so what do they want? How many cubic centimeters of grape juice is added to the current? Okay, so
That'd just be 30 minus
yeah,
23.7.
exactly. What's 30 minus 23.7? 6.3.
Yeah, 6.3.
Okay, so let's draw a new box with 6.3 height. So this is 6.3 height. This is still 10.5. And this is still 20, right?
Right.
Well, it should be 3-dimension. I drew it in 2-dimension. It should be 3-dimension. Okay, so now what they want? They want next grape juice is poured into fill up the rest of the current. How many cubic meters of a grape juice is added to the current?
So would you just find the volume there?
Yeah, exactly.
Okay. So 6.3 times 20
6.3
times 10 and a
times
half.
20. Yeah, exactly. Volume of is that and whatever that works out to be.
I got 1323.
1323.
Yeah.
1323, and the unit should be next. If the grape juice is poured in to fill up the rest, how many cubic centimeters? Centimeters cubed.
Okay. That's a high number, you don't know?
Check the answer on that one. Check the answer on that one.
Okay.
Yeah, that should be right. 1323.
0.7. Let's see what we get. 30 minus 23.7.
Yeah, 6.3.
It's going to be very easy to get the volume of all that grapefruit. So we're going to do 10.5. I'm going to write it as a 323 cubic centimeters of grapefruit juice.
Oh, so we got it right.
Okay, cool.
No rounding necessary. It's a whole number.
All right, that was 40. Find each of its values from a. Okay, so this one's like angles. 40, 41, 42 angles, 43 angles. Find the perimeter of the triangle to the nearest 10th. Okay, so for 44, you graph DAF. Find the perimeter of the triangle to the nearest. Same thing as we did one like this a little bit earlier. Just find the distance between DA.
This formula, and then you
Yeah.
find the perimeter.
Yeah. You find the three distances and you add them together.
Yeah.
45. ABC is dilated by a scale factor of 2.5 and transforms into HIJK. Identify the components of HIJK. HI is that, JK is that, angle M is M, measure of angle H is that. HI, where's HI? Oh, ABCD is dilated by a scale factor of 2.5. You know what dilated means?
That's just multiplication, right?
Yeah, it just basically means expanded.
Right.
Expanded by a factor of 2.5. And it forms the new one, IJK. So after you expand it 2.5, the bigger one is the HIJK.
Okay.
Okay, so let's just do this right quick. 3. Okay, so let's just draw this. Just imagine this was 2.5 times bigger as the one on the right. Something like that. Okay, so where's A? So this is now H. Okay, where's B? HIJK. So something like that. Okay.
Okay.
Okay, so now the length's 8. What's 8 times 2.5? 20. What's 4 times 2.5? 10. What's 15 times 2.5? 37.5, is it? And then what's 11 times 2.5? 27.5, is that right?
Where are you getting 2.5 from? Is it the fraction up there?
Yeah, 5 divided by 2 is 2.5.
Okay.
This is 2.5, right? 2.5. So
Oh.
I'm taking all my distances and multiplying them by 2.5.
Okay.
8 times. I need to check the 15 and the 11 because I'm not sure if I did that right off the top of my head. Let me see. 15 times 2.5 is what? 37. Yeah, that one's right. And then do the same thing for the 11. 11 times 2.5, 11 times 2.5, 27 point. Yeah, okay, we're good. Okay, so now, all right, now what else did we miss anything? The angle will still stay the same. The angles will be the same. This is still 105. This is still 120.
The angles will never change.
No,
right?
no, the angles will not. The angles would. The only thing that would change is the lengths of the lines.
Okay.
HI is 27.5. JK, where's JK? JK is 10. Angle, measure of angle H is 105. Check those degrees. Check those.
Yep. That's right.
Okay. All right, good on that one.
Yeah.
All right, that's 45. 46 rectangle has lengths of that. Similar rectangle might have side lengths of that. For this one, just set up your ratios.
Yeah.
47, a square pyramid picture has a volume of that. Find the height of the pyramid to the nearest 100. Just use your formula for pyramid.
Yeah.
Volume of a pyramid.
That one's pretty straightforward.
All right, 40. Oh, we're only, how many questions is there? 100 something?
It's like 100 and something. Yeah.
170, 200, 170 something. All right,
Yeah.
you want to skip to any specific ones?
Or
Or like 40 something.
maybe actually, I'm pretty sure they're mostly the same. I'm not sure if they're different when they get up to towards the end.
Let's see. Skip down to something. 98. What is the most accurate name for the quadrilateral with coordinates that? I'd have to graph. We'd have to graph it. That one. 99. ABC is a parallelogram. Find the perimeter of triangle CD if the length of BD and AC is that in inches respectively. All right, that one's not so bad. 100, solve for X. For this one, you just set up your ratios. 100. 101, find the area of the composite figure to the nearest 10th. Use pi, but not 3.14. Okay, so for this one, find the area. All right, for this one, you'd break it into 2 parts again. Part 1, find the area of that. Part 2, find the area of that, and then add them together. So actually, you'd break it into 4 pieces. You'd break it into 4 pieces. So 1, 2, 3, and then 4, and then add them all together. 1 and 3 are triangles. 2 is a rectangle, and then 4 is a semicircle. And they're saying the entire height is 14. Okay, so for that one, for the triangle on the left, we know, what do we know? We know that this is 2. Actually, let's do it on here. So let's draw a straight line down here. So the whole base is 12. So this will be 2 here. This will be 2 here. And then this is 8 right here.
Oh, okay. Because you subtracted 12 and 8.
Yeah, to get 4, right? And then so I break that into 2 and break that into 2. Okay, so on shape 1, this is shape 1, shape 2, and shape 3 and shape 4. So shape 1 is the same as shape 3, right?
Right.
So let's look at shape 1. Here's shape 1. I didn't draw too good. That's okay. So this is 2. What else do we know? Anything else? Do we know the hypotenuse? No. Do we know the height? Do we know that? Yeah, we know. Okay, let's come back to the. Let's just work on work on the semicircle. Okay, here's your circle. Because we're gonna need this height. Actually, we're gonna need this height right here. Okay, so here's our circle. What's the area of a circle formula? Area of a circle is what? Pi r squared.
Yeah.
Okay, so what's the radius on that? What's the radius? Oh, this is okay. The radius is 4, right? The whole thing is 8. This whole thing is 8. So this is 4 and this is 4. So radius is 4. So if radius is 4, that'll be 4 squared is just 16, right?
You sure the radius isn't 8 or?
Well, this whole thing is 8 right here.
So that's the diameter.
That's the diameter, exactly. So the radius will be 16. So the area of the circle would be, now we're taking half of that because it's a semicircle. So the area would be 8 pi. Because it's half of the circle, not the whole circle, right?
Right.
Okay, so we got that part done. Got this done. Okay, so now what do we know? We know the area is 8 pi of number 4, part 4. Now we know the area of part 2. What's the area of part 2? Length times width. This is 10 right here, right? 10.
Also, how do you solve for like pi? Like, what do you do there?
Just leave it as pi. Just leave it in terms of pi.
Okay.
Actually, this is not 10. This is what, 8? This is 8, my bad. This is 8. This is 8. What's this vertical distance from here to here?
So maybe, all right.
Do we know the triangle, the height of the triangle?
Let's figure it out.
We know this is 2. We want the h there. And it's the same thing as this triangle. This is 2. This is h. This is 90.
This one is a little confusing.
Yeah, all we need is this one h value. Once we have that, we'll find we know the rest of it.
Maybe the formula of a triangle?
Say it again.
Maybe we can try, since the bottom shape is a trapezoid, maybe you could try the area of
Oh
the
yeah, right. There is a formula for trapezoid formula, right?
yeah.
Right, exactly. We don't need to break it into 4 pieces. We just need to break it into 2 pieces. Yeah, that's right. Yeah, my bad. All right, forget the triangle. What's the, okay, we got the area of the semicircle. What's the area of the trapezoid? Or whatever this shape is called on the bottom. I think it's trapezoid.
Yeah, trapezoid.
Trapezoid. All right. What's the formula? I forget what the formula area for
Trapezoid is A equals 1/2
Uh-huh.
parentheses
What?
Huh?
Say it again.
H parenthesis B1
Base 1, yeah.
this one plus base 2.
Did I write it correctly like that?
Yeah, just like that.
Okay, yeah, that makes more sense. Yep, that makes more sense. All right, so half base 1 plus base 2 is 20, right? 12 plus 8. All right, let me write the whole thing. And what's the height? The height would be, what's the height there? Base 1 is 8 plus 12 in brackets. And then the h is what? H is, what's this distance right here?
The distance is still not a problem.
Okay, so actually, what's this distance right here? This is 4, because this is a
4.
radius.
Yeah.
So this has got to be 10.
So that would be 10 then.
Exactly. So now just plug everything in and solve, right? 8 plus 12 is 20, half of 20.
For the height, you wouldn't just do 14 instead of putting 10, or?
Well, the height of the trapezoid is this. The height of the whole thing
yeah.
is 14.
Right.
We just want this height right here,
Yeah.
which is 10.
And
So yeah, so this is 100. So now just add the two together.
wait,
So area total equals area total equals 8 pi plus 300. 8 pi plus 100. My bad. 8 pi plus 100.
are you sure 1/2 times 10? Wait.
Yeah. Because remember, this right here is a radius, right?
Yeah.
That right there is a radius. This right here is a radius. This right here is a radius. So that's a 4, that's a 4, and this is a 4. If this is 14, this whole thing, and this part is 4, this height has to be 10.
Okay.
That's how I'm getting this 10 right here. Half of 10 is 5. Half of 10 is 5. 5 times 20 is 100.
Okay. And now the total. So you just write 8 plus.
8 pi plus 100.
Okay. So we got 8 pi from
The semicircle. The area of the semicircle.
okay. Let me take a photo of this.
Yep.
So how did you get 16 again for the semicircle?
Radius squared. Pi times radius squared is the formula.
Okay.
And the radius is 4, right?
Yeah.
4 squared is 16.
Oh. Okay.
But that's of the whole circle, right? That's the area of the whole circle.
Yeah.
We only want half of that. So take 16 divided by 2, which is 8.
Okay.
Is that what you got? 8 pi plus 100?
Check real quick. The page is 20.
Graph.
Oh, she got like 125.1. That's what she got.
Oh, 125. Well, yeah, she just put 3.14 in here.
Oh.
See what it says? No, my bad. It says round to the nearest 10. My bad. Just multiply it out. Just multiply it out.
So then you would just have 8 times pi?
8 times 3.14 times plus 100. Or use the whole thing, right? It says right here, use the pi button, not 3.14. So 3.14 blah 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 plus 100.
Oh, okay, so it'd be 125.1.
Yeah,
okay.
there you go. There's your 125 point whatever.
Okay.
Get it?
All right, so we went over density, distance formula.
Yep.
Like volume, area.
Yep. What else did we do? We did
could we do one more graphing one and that would be all?
All right.
Maybe.
All right, which one you want to do?
Let me find one. Maybe 103.
103. Okay. Triangle ABC with coordinates. Okay, let's graph the 3 coordinates. -2, 1, -2, 1 is right here. 3, 1 is right here. And 0, -3. 0, -3 is right there. Okay.
Okay.
All right, let's draw that triangle right there.
It's a rotation question.
All right. All right, so there's our first one, right?
Yeah.
So A's right there. B's right there and C's right there. Okay. undergoes a reflection across the line y equals 3. Okay, so let's draw our y equals 3. Y equals 3 is right here. Undergoes a reflection across line y equals 3, followed by a rotation of 180. Graph and label the coordinates of the new one. Okay. Let's do it step by step then. Let's do it like this. A -2, 1. B 3, 1. And C is 0, -3, right?
Yeah,
Okay, so that's the original, right? This is your original points, right?
correct.
Okay, so next one would be undergoes a reflection. So reflection about the next ones we're going to write here would be the reflection reflection of y equals 3. Okay, so what is this one now? What is this
So,
one now?
so you would just -3 from
Not -3, but okay, so CA is -2, 1.
yeah, so it'd be -2 4
-2, 5.
5.
See how this distance right here is 2? It'll
Yeah.
be the same distance 2 there. Okay, but okay, so then this one is -2, 5. That's
How'd you get like the extra number?
how did I get which extra number?
For 5, because 3 plus 1 is 4, no? Or
3 plus 1 is 4. Okay, so 2, 1, 1, 2. If I was reflected about the line y equals 3. Yeah, it'll be reflected about the line. You don't add the 3 to it. Actually, let me do it in a different color. Let's do it in blue. So this one would be the new one. Okay, see this distance is 2 right here.
yeah.
This distance would be 2 right here also.
Oh, so what do you do? How do you solve that reflection?
You don't have to solve it. You just have to get the coordinate.
So you write,
Yeah, this will be the new A, and then same thing with the B. This distance is 2, so this distance will be 2. So that's your new B.
oh,
What point is that? 3, 5, 3, 5. So this one is 3, 5.
okay.
This one is -2, 5. And then what's C? Same idea with C.
So, B. Well, B is also
We just
Yes,
did B. So the 0, -3. What would that one be?
um
Okay, this distance is how much? 6, right?
yeah, 6.
So
So
there's your new one right there. Get it?
yeah.
Okay, so
Oh, that makes sense. Yeah.
okay, we're not done though. We got to do one more thing after that. So there's your reflection about the y. All right, so let's graph that. All right, so what was C? C was what? 0, 9, 0, 9. Okay, so that's the second step, right? Original, reflection about y, and then the last one is rotation of 180. Rotation of 180.
Yeah.
Rotation 180 degrees. Okay, we're gonna go to Google. So we're gonna figure out what this one is, what this one is, and what this one is. I just got a rotation about 180. I think you just
You go counterclockwise or clockwise?
you would go clockwise.
Okay, so
You go this way.
all right, so then -2, 5.
Yeah, what is that new one? Let's do
Alright.
that one in green. Let's do that one in green. Okay, so
It would then be +2, -5, I think.
+2, -5. Let's think about that. +2 would be right here. -5 would be down here. That makes sense. Okay, what's the next one?
You have 3, 3, so
So what you're doing is just keep flipping the X. So this would be -3 and
-5.
-5,
Yeah.
-3, -5, and then the last one.
The last one you have 0, 6. So that would just be
6 or 0, 9. 0, -9.
oh, is it 0 neg? Oh,
All right, so 0 and -9. Let's
oh yeah.
that. Okay, so which one's A, which one's B, which one's C? So 2, -5 would be A prime, B prime, C prime. Check the. Well, let me Google the reflection about the 180 just to make sure if that's right. Well, it seems like it's right. Let me just double check that. What I want to Google rotation of 180.
Yeah, we got it right.
Okay, all right, cool. Let me rotation. Can you on that cheat sheet that they give you, can you bring it to class or does she give it to you?
Oh, they give it like look, they have this little reference sheet right here.
Oh.
Just everything.
Where am I? Oh, I gotta stop sharing. Maybe that's why. What I was gonna tell you to write. You know the like rotation of 90, rotation of 180, rotation of 270. I was gonna tell you to write the original XY and then the new translation on that sheet.
Okay, I'll write it right now then.
Let me Google. Let me show you what to write for a rotation of 180. Right. This is what I wanted to show you. The prime would be -x, -y.
So wait, what happened?
Oh shit, did I erase it? Oh shit, I erased it. When I stop sharing, it goes away, my bad. But the way you, can I undo this or no? I think when I stopped sharing it, but the way you did it, like that from, it was 3 steps, the original, the reflection about the Y, and it's like 3 steps, the original, the reflection, and then the rotation. So just set it up like the original XY.
Just set up a diagram.
You could set up a diagram, or you could like set up the steps, then just diagram the very last coordinates.
Okay. So just I think the formulas is it. Just if you get the formula, then you're good.
For that one, there's no real formula, but
no, I mean like for everything, really.
Yeah, you just got to know when to use which formula.
All right. Thank you.
All right, that's it.
Yeah.
All right, yeah, there's a lot of questions here, man.
Yeah, no. There's no way we could do all of them.
Yeah, this is just too much for one day. 100 questions. When did they give this to you? Last week?
Yeah.
And so your finals tomorrow?
Yeah.